Folks, hello and welcome to the SQL Bits 2022. My colleague Rohit and I will talk about some network security and
Can you share
connectivity.
your screen, please? We're not seeing it at the moment.
Okay, do you see it now?
Yes, thank you.
Okay, thanks for reminding me.
Thank you.
So, yes, so my colleague Rohit and I would talk about some network security and connectivity features that are coming with both SQL 2022 and Azure SQL. Yeah, just okay, and here is our agenda today. We are very excited to present a new version of TDS protocol, TDS8, that comes with this kind of strict encryption type that brings some additional security benefits. One of them would be TLS 1.3 support. But this is not all. You will hear more about this soon. Because we know how much TLS version is important, we are also showing now that in the audit logs, and you will be also able to see that as well. The other important topic when we are talking about the networking and security is obviously data exfiltration prevention for especially in today kind of security sensitive world. So for that, we introduced two features, one for Azure SQL DB, the other one for Azure SQL Managed Instance, that each in its own way kind of tries to solve this problem. Yeah, let's start with this TDS protocol. And on this screen, you could see current version of this protocol. And if I just go a bit deeper into it, what you could see is that this kind of pre-login and request and respond messages go in clear text. And only after that, when encryption is negotiated, we switch to the TLS handshake, and then authentication and data exchange comes in encrypted format. And I mean, from the security perspective, this is all good because these pre-login and request and respond do not contain any kind of sensitive information. But still, we wanted to kind of make all TDS encryption connection end-to-end encrypted. So we swapped a bit these messages and put TLS handshake at the beginning. So now everything goes encrypted. Now, there are a couple of reasons why we did that. So first reason is that we kind of heard from customers and from the industry that now encryption is mandatory. And if you know what happens in the cloud, in Azure, you know, kind of this encryption is mandatory. And we even insist of using the latest and greatest TLS protocols. But that is just one reason. The other reason that might be very important to you, because it enables some additional scenarios, is this alignment between TDS and HTTPS as encrypted web protocols. Because what this enables, it enables basically to use all these networking appliances that know how to handle web traffic very well to use all of their capabilities for
15 minutes
for
left.
TDS as well. Also, additional benefit is now this removal of TDS TLS interleaving that happens when we kind of move from pre-login message to the TLS handshake, and this one actually provides seamless introduction of TLS 1.3 and will help bring all other kind of encryption improvements in the future. So Uh, we enabled with SQL Server 2022, we brought TLS 1.3 support. And as I mentioned on the previous slide, this is enabled, but TDS 8. One thing worth noting is that TDS 8 supports also the previous TLS versions. So we understand that many of our customers would still utilize TLS 1.2. So yes, no worries. You could still keep TLS 1.2 and use this TDS 8 for the other value props it brings. Uh, TLS 1.3 is important as it deprecates by standard weak cipher suits and also helps improve latency and performance through the reduced number of round trips. If you run a SQL Server on Windows, you will need Windows Server 2020 for that. The reason is that SQL always uses underlying OS APIs in order to um, provide encryption, and TLS 1.3 is only available from Windows Server 2022 and on. Uh, Now let's talk a bit more about this strict connection encryption that I've mentioned. So with this strict encryption, first, because it utilizes TDS8 underneath, the encryption is mandatory. But we also kind of use this change to deprecate some practices that are not considered good anymore. And one of them, obviously, is that trust server certificate that you could see on the right part of my screen is grayed out. Uh, of course, we know that not in all cases kind of what is in certificate could match server name. So for that, there is this host name and certificate option that currently some of the drivers provide, but all the new drivers would provide it. And we also plan to introduce certificate pinning. The next thing that would also not be used anymore with strict encryption is this auto-generated fallback certificate that is automatically generated by SQL Server if you do not specify it. So if you want to use this strict connection encryption and force it on the server, you will need to provide a certificate because we would want just to enforce all the good security practices. And this is maybe more a cosmetic change, but brings clarity because we introduced also new aliases. If you, as you know, currently we have these encrypt options true and false, and now we introduced aliases for them like mandatory and optional. That brings additional clarity because many people thought that if you set encrypt equals false on the driver, that means the driver the connection would not be encrypted, and that's not the case. It just means that it's optional, and server side it could be also enforced. So for that reasons we introduced this kind of thing. And now, yeah, let me quickly switch to the encryption demo.
Just to let you know, there's 10 minutes left.
Thank you. Basically, what you see here is this OLEDB connection, and and in the background, I started up a Wireshark so we could see what happens underneath. You see here that I put connection encryption to the strict mode. Host name and certificate is not needed in this case, and now I will just test connection and see that this connection is successful. And if we now look briefly into trace, you will see that it closely resembles what you have in web apps. You have this starting client hello, and then you have server hello with a certificate, and then just application data. Yeah, let's go back to the slides. Why is this important? It imports some exciting scenarios that before we had just with web apps. For example, think if you have two SQL servers behind a firewall that is, for example, Nginx, then you could use this endpoint and use server name in a in TDS protocol to distinguish between two. And here is, for example, that configuration. Basically, Nginx would pre-read what server you're trying to reach, and based on that, could repoint the connection to the one or the other. Before handing this over to Rohit, I would just like to announce this cool feature that is now available in Azure SQL, where you could now in audit logs detect the TLS version and kind of ensure that the version that you expect is really how connections are done. With that, I'm handing this over to my colleague Rohit.
Sarjan, yeah, good. I think I should be able to share my screen now. It's not letting me share my screen for some reason.
Okay, then I will share the screen with the slides and help navigate
Sure,
it
go ahead.
for the
He has to turn his camera off to be able to share your screen,
Okay,
or
let
you
me do
could
that.
try that.
and then it should let you do it.
Okay, great. Yeah, I'm able to share my screen. Okay, so we have less than 7 minutes remaining, so let me start talking. All right, folks. So hopefully you can see my screen. And what I'm going to talk about today is data exfiltration prevention. And in a very short manner, what I'm showing you on the screen is what it's all about. You have a specific Azure SQL database that talks to various storage accounts or other databases, say to write, export a backup or what have you. And data exfiltration prevention is the capability to basically have a sort of a perimeter around your SQL database such that you can define which are the valid resources that it can talk to, right? Way we accomplish this is by having a switch at the SQL Server level, logical server level, and an allowed FQDN list. So that way you can control and ensure that your database is not writing a backup to somebody's personal storage account, and you can limit it to only the storage accounts within your org or within your subscription. Currently, it works for these particular set of features, which are mainly oriented towards writing to Azure storage. Next, let's talk about how data exfiltration prevention will be done with managed instance. Now, most of you will be aware, managed instance resides in its own VNet and subnet. And the way it stands today, it can talk to any storage account. Like as you see these two storage accounts on the right-hand side, it can talk to them provided the specific rules are open on the subnet NSG. What we want to do is be able to tighten that up so that we can eventually, our aim is to make sure that it can not talk to the unsafe storage account, right?
There's 5 minutes
So
left.
let's see how we get there. So first thing you need to do is enable service endpoint for Azure storage. That makes sure that all your traffic stays within the Azure boundary. And then you need to, but it still doesn't solve the problem that you can still talk to both these accounts. You then enable what's called a service endpoint policy and just allow it to talk to the backup storage. And this way now you have data exfiltration prevention in managed instance. Last but not least, let's talk about IPv6. Today, customers are running out of IPv4 addresses. IPv6 solves the problem by just scaling out the number of addresses in a massive way. So very unlikely that we'll run out of this. And what we are doing on the Azure SQL side is giving you the same parity that you had with IPv4 firewall rules. And we're building support for IPv6 in the various client drivers. So at the end of the day, we'll be able to connect from a client that's using IPv6, allow listed, using the same thing that you do today in Portal, right? Let me show you a quick demo of this. Of course, this feature is in early development, so the demo is recorded, and I apologize for that. So hopefully this plays. Okay, so as you can see here, what I'm showing you here is the standard message that you get when you try to connect from a client using IPv6. It will actually show you the IPv6 address and say, hey, you need to allow list this in order to be able to connect. On this screen, I'm connecting via IPv4, and then I go check a particular DMV called sys.ipv6 firewall rules, because this is where I will be defining my IPv6 rules. And currently this is empty, which is why nobody can connect. I'll also check sys.firewall rules, where I have a rule for my IPv4 address, which is how I'm able to connect now. Next thing I need to do is go in and add that rule for IPv6. And the way I do that is by specifying a rule name and the a client IPv6 address. So the syntax is exactly identical. All this does is add a IPv6 firewall rule, right? And you can see that now in the DMV. Next, I need to now connect, and this time my connection goes through. And I can go query sys.dmexec connections. And what I see is I'm actually connecting using the IPv6 address, right? So that was just a very small demo of the value prop here. And I think with that, we are at time. So we want to thank you for attending our session and spending your time with us today. We welcome your Q&As. You have our names and email addresses. Feel free to reach out to us, give us feedback about our session, our features, and that is it for now. Thank you.
Thank you.